Okay, this is section 4.1, and today we're going to start a chapter all about trig. And we start off that chapter by talking about radian and degree measure. I know you've seen this before in Algebra 2, and we're going to kind of take it a couple steps farther here in pre-calc. So to start out, we want to be able to talk about angles in a couple different ways. One is standard position, and this just means that if the vertex is at the origin, and initial side, so it starts, the angle starts on x-axis. And that is literally every, well, I shouldn't say every, but most of the angles you've ever seen. So they all have their vertex right here, and they start here and kind of open that way. So this would be an angle in standard position. Positive angles are measured counterclockwise. This is again what you are used to, starting at the x-axis and going around. So this is positive. Clockwise is how you measure a negative angle. So you can measure 45 degrees up, you can also measure 45 degrees down, and it would be a negative 45 degrees because it's going clockwise direction. There are a couple of different ways to measure angles. The main two ways to do it that we talk about are degrees and radians. It is kind of like talking about inches and feet. So you're talking about the same distance, talking about the same angle, you're just measuring it in two different ways. And radians are 1 radian is equal to 1 radius on the circle. And I'll kind of explain what I mean by that. If you were to come over here and measure from the center out, which is a radius, and imagine that that was a piece of string, so I laid a piece of string there so it's kind of wiggly, kind of bendy. And if I took that piece of string, that distance, and laid it along the outside edge, as long as, or the distance it would reach is called 1 radian. So if I took 1 radius and laid it on the outside edge, that distance would be called 1 radian. If I laid it again, that would be 2 radians. A third one would be 3 radians. And interestingly, to get all the way across at 180 degrees, it's 3.14 radians, which is pi. That's kind of where that comes from. So now you know where pi originated. It's how many radiuses you would need to lay around the circle to get to 180 degrees. And that works for any circle, doesn't matter how big it is. If you take the radius and lay it out, you're going to have 1 radian. It's about equal to 57.3 degrees. About, when you measure that out right there. So using our unit circle, we're going to start to fill in some of the degrees and the radian measures on our circle. There is a third blank here if you've seen the unit circle video, and that is for exact values, and we'll do that in the next lesson. So to start here, we're going to start with 0 degrees. We just talked about how all the way on the other side is 180 degrees. In the middle would be 90. Half of that would be 45. And then the special right triangles that we talk about when we talk about the unit circle is the 30 and the 60. So if you notice a pattern at all, 45s are right in the middle, kind of like a duh, it's halfway. And then 15 degrees on either side are the angles we're talking about. The 30 and the 60 are also 30 degrees away from their axes too. So if I take 90 and add 30 degrees, I'll be at 120. If I add 15, 135. Add 15, I'll be at 150. Add 30, I'm at 180. Add 30, I'm at 210. Add 15, I'm at 225. Add 15 again, I'm at 240. Add 30, I'm at 270. 300, 315, and 330. So just kind of continuing that pattern. Those are the angles that we talk about when we talk about a unit circle. To do radian measure, it's very similar. Lots of patterns about how it works. So this starts out with 0 radians. If I haven't gone any degrees, I also haven't moved any radians either. And remember, radians is a measure along the outside of the circle. So we're talking about how far did we travel. We just talked about above how all the way over at 180 is going to be pi. So then if I were to go straight up, that would be half of a pi, and we write pi over 2. Half of that at 45 degrees, so a half of a half would be a quarter, so this is pi over 4. That also kind of corresponds to the fact that there are 4 45s, 1, 2, 3, 4 in 180. So if I took 180, just that half, and cut it up into 4 pieces, I would get a 45 degree angle. The 30s, how many 30s does it take to get into 180? That would be 6, so this is a pi over 6. And 60 degrees into 180 would be a pi over 3. And in the unit circle video, I do explain how those patterns go. So I'm going to kind of do it quickly here. If you want the real skinny, go and watch the unit circle video. So starting with my pi over 6, I'm looking for an unreduced fraction. So I'm just going to keep increasing the numerator. So here's 1 pi over 6. 2 pi over 6 would reduce. The 2 and the 6 could reduce. 3 pi over 6, they could reduce. 4, they would reduce. 5, they couldn't. They have nothing in common. So 5 pi over 6 is my next 30-degree angle. So that's that guy. Continuing with that, 6 pi over 6, the 6's would cancel. 7 pi over 6 does not, so that would go here. 8 pi over 6 would reduce. 9 would reduce. 10, they would have a 2 in common. 11 pi over 6 is the next number that doesn't reduce, so that goes right here. I'm going to do the same thing with my over 4s. So right now I've got a 1 over 4. Then I'd have a 2 over 4, which would reduce. 3 over 4 does not, so that goes on the blank. 4 over 4 reduces. 5 over 4 does not. 6 over 4 reduces. 7 over 4 does not. So I'm just looking for fractions that don't reduce and putting them on the blanks. Starting with 1 pi over 3. 2 pi over 3 does not reduce. 3 pi over 3 would. 4 pi over 3 is the next one. 5 pi over 3. And all I have left is this guy down here. So this was a pi over 2, which is like a half of a pi. This was a full pi. So this would be a pi and a half, or 3 pi over 2. The last thing that we're going to cover in this unit is just how to, or I'm sorry, this lesson is just how to convert between radians and degrees. It's very much like converting between inches and feet. So just knowing how to move between one unit of measure and the other. Just like inches and feet, you have to have a conversion factor, and we do. On our unit circle, the easiest one to use is a pi and 180. There's no real fractions involved with these guys. They're each kind of a standalone number. Everybody else has kind of got a fraction going on with it, and it's a little harder to work with. So we're going to use the conversion factor of pi over 180 degrees, or depending, you might need 180 degrees over pi. So when you're converting, what you're trying to do is get rid of the unit of measure. So the only one that'll help me get rid of the degrees is to have degrees in the bottom. So I'm going to do pi over 180 degrees. The degrees will cancel, and I'll end up with 50 pi over 180, but we want to reduce that. It's kind of a really big fraction. So I'm going to take a 0 off of there and end up with 5 pi over 18. 2 radians is like a measure around the circle, just like here. So this would be 2 radians, so we're talking about that angle right up there. And its unit of measure right now is a radian, which is what pi is. So we want to multiply by 180 over pi. Pi technically has a radian label. We just don't usually write it. So canceling off the radians, I now have 2 times 180, which I'm doing in my calculator. I'll get 360, and then I'm supposed to divide by pi. And make sure you use the pi button, not 3.14. You kind of want to use that repeating decimal. So we end up with 114.59 degrees. Make sure you put a degree symbol on there so that everybody knows you're talking about a degree measure. Last one is 6 pi over 7. So we're going to multiply by 180 over pi. We need our pi's to cancel. And so now just doing this math, I have 6 times 180. And then I'm going to divide by 7. And I end up with 154.29 degrees. So being able to work around a unit circle, being able to know these values and kind of how and where they come from, or knowing enough about the patterns to see how to fill them in, and then being able to convert between radians and degrees.